Which of the following options accurately describes the role of the C parameter in scikit-learn's sklearn support vector machine SVM classifier? A. Controls the complexity of the decision boundary. B. Determines the kernel function used for nonlinear data. C. Influences the trade-off between minimizing training error and maximizing margin. D. All of the above. A higher C value prioritizes minimizing training error, potentially leading to a more complex decision boundary and a risk of overfitting. Conversely, a lower C value emphasizes maximizing the margin, resulting in a simpler decision boundary that may generalize better to unseen data. Correct. The kernel function is selected independently from the C parameter. Common kernel functions include linear, polynomial, and radial basis function RBF kernels. Each kernel has its strengths and weaknesses, and the choice depends on the nature of the data. Incorrect. The C parameter directly controls this trade-off. It acts as a regularization parameter, balancing the need to fit the training data low training error while avoiding overfitting by ensuring a large margin between classes. Correct. As A and C are correct and B is incorrect, this choice is correct. The C parameter influences the decision boundary complexity and the trade-off between training error and margin. Correct. D. All of the above. A supervised machine learning algorithm used for classification and regression. It aims to find the optimal hyperplane that separates data points into different classes with the maximum margin. In a spam detection system, an SVM can learn a hyperplane to distinguish between emails that are spam and those that are not. By maximizing the margin, the SVM can better generalize to new, unseen emails and reduce the chances of misclassifying them. A decision boundary that divides data points into different classes in a multidimensional space. It's represented by an equation in the form of WXB0. Consider a dataset with two features x1, x2. The hyperplane in this case would be a line that separates the data points into different classes. The equation of this line would be W1x1 W2x2b0. The distance between the hyperplane and the closest data points from each class. Maximizing the margin is a key objective in SVMs to achieve good generalization. A wider margin indicates that the hyperplane is well separated from the data points, suggesting that it's less likely to be affected by noise or outliers in the data. Data points that lie closest to the hyperplane and define the margin. These vectors are critical in determining the optimal hyperplane. In a dataset with two classes, the support vectors would be the data points that are closest to the hyperplane that separates the two classes. Functions that map data points to a higher dimensional space, allowing SVMs to handle nonlinearly separable data. Examples include linear, polynomial, and radial basis function RBF kernels. Imagine a dataset where data points cannot be separated linearly by a hyperplane. By applying a polynomial kernel, the data is transformed into a higher dimensional space where a linear hyperplane can effectively separate the classes. A technique used in machine learning to prevent overfitting by adding a penalty term to the loss function. The C parameter in SVM is a regularization parameter that controls the strength of this penalty. When C is high, the SVM tries to minimize training error, potentially leading to a complex decision boundary and overfitting. However, a lower C value encourages a simpler decision boundary, promoting better generalization to new data. Image classification. Classifying images into different categories, such as recognizing objects, faces, or scenes. SVMs can be used to classify images of different types of animals, like cats, dogs, and birds. Text classification. Categorizing text documents, like spam detection, sentiment analysis, or topic identification. SVMs can be employed to filter spam emails by learning to differentiate between legitimate emails and spam. Bioinformatics. Analyzing biological data, such as identifying protein structures or predicting gene expression patterns. SVMs can be used to classify proteins based on their amino acid sequences. Fraud detection. Identifying fraudulent transactions or activities in financial institutions or other domains. SVMs can be used to detect fraudulent credit card transactions by learning patterns in transaction data. Medical diagnosis. Assisting in the diagnosis of diseases based on patient symptoms and medical records. SVMs can be used to classify patients into different disease categories based on their medical data. Consider a dataset with two features x1, x2, and two classes Class A, Class B with the following data points. Class A 1, 2, 2, 1, 3, 3. Class B 4, 5, 5, 4, 6, 6. The hyperplane equation can be represented as W1x1 W2x2b0. To maximize the margin, we need to find the values of W1, W2, and B that maximize the distance between the hyperplane and the closest data points from each class support vectors. The C parameter in SVM influences this optimization process.